Yes, you can continue. You can start.
Um, my PPT is visible, sir.
Yes, it is visible. Yes, visible.
Okay.
Yes, it is
Uh,
visible.
okay. Okay.
Slide is
Uh,
visible.
okay. So for the network issue, that time I didn't go for continuity. So now I'll go for hardware part also and also software part. Okay. So my name is Riju Nandi, a PhD scholar of NIT Rourkela under the supervision of Dr. Arnab Ghosh and Dr. Krishna Roy sir. So uh, that time introduction also I have discussed also. So we use maximum power tracking in solar PV panel to ensure that a maximum energy extraction of the solar panel under various environmental conditions. So solar panel operate most efficiently at the specific point called the maximum power point. Okay. So where the product of the voltage and current is the at the highest, giving the maximum power point. Okay. So we'll go for Petrap and observe, Perturb and observe method, MPPT. Okay. The concept behind the P and O method is to modify the operating voltage and current of the PV panel until you obtain maximum power from it. Okay. The tracker operated by periodically incrementing and decrementing the solar array voltage. This method is fail under rapidly variation of the environmental. Okay. Uh, Suppose cloudy weather is coming. That time that method has been failed. The sign of the PV module voltage is also verified to adjust the duty cycle for eventual update and correction. Um, so this is the flow chart. Okay, this is the flow chart. So there is a we know that power equals to VT into IT. So this if del P, suppose this is a del P, PT minus PT minus 1. Okay, so PT is the present value and PT minus 1 is the old value. Okay, so equals to delta equals to 0 means del P equals to 0. If it is true, going to the maximum power point. If it is false, going to del D greater than 0. Then if it is true, going to del V greater than 0 means VT greater than VT minus 1. Also, if it is false, then similarity VT greater than VT minus 1. Okay. Again, if it is true that decrease the VT means decrease the DT ratio variation of DT ratio means DT minus GT minus 1 also. Okay. There is also if it false, it is increase the DT ratio, increase VT. Okay. If it is true like that for this case, if it is true, increase the VT means DT ratio increases means DT variation of DT ratio increases. Also decrease the VT ratio. Okay. After the programming, okay, after the programming, we got the new PV voltage and current. Sorry, V and to I. That product of V and to I will get the maximum power point. Okay. So this is the curve of the P and O. Okay. At the extreme point of any PV curve, MPP is given by TPPV by DVPV equals to 0. Equals to MPP means this is the DPPV. This point is DPPV by DVPV equals to 0 equals to MPP. The position of MPPP is determined by either left side, this side, either right side. Okay. If dPPB by dVPB greater than 0, left side of the PP means this side, dPPB by dVPB greater than 0. Okay. For the right side, like opposite, dPPB by dVPB less than 0. Okay. So now I'll go for the hardware section. Okay. Okay. For Petra and observe, part of observe, I'll go for hardware now. Okay. Then I'll come also PSO and fuzzy. Okay, for this three part P&O, fuzzy and PSO. For this, I'll go for hardware part. Okay, so Hello, am I audible, sir?
Yes, audible.
Audible. Okay. 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 So this is my first setup of the MPPT. Okay. You can see. Uh, so this is the load. Okay. So uh, the load. Okay. Uh, I fixed the load is 18 voltage. Sorry, 18 ohm. Okay. So uh, 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 this is the supply circuit. Okay, this is supply circuit. This is plus minus 15 voltage supply circuit. Okay, this is the voltage and current sensor circuit. Okay, for the closed loop of the MPPT, we use the voltage and current sensor. Okay, for the voltage and current sensor, we have to do calibration. Okay, have to do calibration. Okay, 1 minute. Okay, 1 minute. Okay, let's continue. Okay. We are talking about the voltage and current sensor. So uh, for the making the voltage and current sensor, we have to do the calibration. Okay. If you don't do the calibration, some it won't it affect is the effect on the result. Okay. So we made in our lab all the power supply voltage sensor circuit. Okay. Uh, and this is the boost converter. Okay, we have used the boost converter for the MPPT. Okay, this is the boost converter we made in the we made PCB in my lab, our lab. Okay, so this is the voltage and current sensor protection circuit. Okay, it's a protection circuit. This is the Arduino at Mega circuit. Okay, so this is the driver circuit. We have used the driver circuit TLP250. I have been used TLP250 driver circuit to drive the boost converter. Okay. For the power supply of the driver circuit, we have used the on supply circuit. Okay, plus minus plus 15 volt supply circuit. Okay. There's the inductor is there. Okay. Uh, uh, we made the inductor. So I made the inductor. Okay. Both input side and output side capacitor is there. Okay. If you know the MATLAB programming the piano, you know the in input side and output side both are a capacitor is required for the reduce the voltage harmonics. Okay, so that I have been used that in that is also protection circuit, but this is the gate protection circuit. Okay, so okay, uh, okay, now so this is the our ammeter. Okay, this is the current flow. Okay, this is the our oscilloscope. So now there is a in the rooftop PV panel is there. Okay, from the PV panel supply means the supply voltage has come. Okay, this is the connection. This is the connection of the PV panel. Okay, connection is the come. Okay, so we have to First, okay, first we have to fix the voltage. Okay, then we have to on the supply. Okay, the supply. You can see now the current rating is 2 ampere. Okay, the current rating is 2 ampere, and the voltage. This is the V in voltage. Okay, you have to measure the VPV. This is the IPV. This is the VPV. Okay, you can see the voltage is 37 voltage. Okay, you can see it is the 37 voltage because of sunlight. Now sunlight is low, that's why current is low. Okay, now we have to, if I um, if I decreasing the resistance value, okay, you can see current is increasing, okay, current is increasing. Okay, so have to measure. Okay. And 5. Okay. Resistance increasing. Okay. Current is increasing. Okay. Now it's 23 ohm. Okay. So you can see now current is 3 ampere. Okay. I have to tell about this. This is the Arduino Mega. Okay. You have to put uh, in this Arduino the P and O technique and PSO technique and any fuzzy technique, any technique you have to control. Okay. That P and O technique I have to build. So I build the P and O technique in the Arduino at Mega. Okay. uh, you can see that A0, A1 is the input. Okay. In Arduino, A0 is the VPB and A1 is the IPP. Okay. And and output is the three input. The 3 point is the output and ground. Okay. Is the three outputs is going. That output goes to the driver circuit and uh, and uh, and produce the produce the duty ratio in the gate circuit. Okay, gate pulse. Okay, so you can see uh, this is the power circuit. Okay, this is the power graph. This is the voltage. This is the current. Okay. Uh, okay. Okay, take 1 minute. Oh, okay. You can see. So after on the power supply, both power supply, after the gate pulse, if I run and stop, then I got the uh, I got the pulse. Okay. Because that pulse like that because of protection circuit. Okay. That if I remove the protection circuit, that time a pulse is much be greater. Okay. So uh, uh, so this is the okay the voltage the voltage. Acha, हाँ. So hmm. So if you go for measure, okay, okay. Uh, you can see that this is the power graph. Okay, this is the power graph. This is the voltage graph. Okay, voltage is constant in I think 38 voltage, and current is constant. And suppose 3 point near about 3.5. Okay, so I got like near about 240 watt. Okay, near about 240 because now sunlight is low. That's why I got 240 watt like that, 240 watt. But if sunlight for the PV panel, for our PV panel, the specification is for like near about 320 watt. Okay, 300 to 320 watt. Okay, but we now we got the 240 volt. Sorry, 240 watt. If sunlight is it at morning time like 12 p.m. and 1 p.m. that time voltage is maximum. Okay, that time current also maximum. We got the current is near about 8 ampere. Okay, that time we got 320 watt. Okay, so now is the sunlight is low. That's why we got the 240 watt. Okay, you can see that if now is the voltage. Okay, if you see, okay, if you see that the voltage. Okay, this is a voltage circuit. Okay, the voltage if is voltage like 1, 2, 3. Okay, suppose this is the voltage you got 38 voltage and current like that 3 ampere. Okay, and power you got that this is the power graph. Okay, straight line. Some fluctuation is there, but power is got you got the steady state power output. Okay, like like at 250 watt. If you run the stop, you got the also pulse of the D to ratio of the gate. Okay, through P and O, you got the pulse and get the maximum power. Okay, okay. For this is the for PO now. Now I'll go for PSO technique. Okay, so now I'll go for theory part PSO. Then I will again I'll come for also hardware section. Okay.